Like I'm also having some because of change of weather. Little head heaviness is there, so I have to be careful in talking. So, students, you listen. Now you are in final year. You should be mature. Like you don't need monitoring, policing. I won't take attendance and then you check all that. So it is all about self-discipline. Okay, just let me repeat. You are in final year. You are about to take up your internship. So again, your mentor, the manager, they will not monitor you day by day. But what will happen if you don't work continuously? You may not get the results, and then the attitude will change. That they will know because of their experience. They will know because they may call at any time for any query. They may call at any time to send the result immediately. How can you send the result immediately without working? So with this, I'm closing. So it is all about just I'm telling. Leave. I'm telling again. Leave the grade, leave the placement offer, attitude. Attitude is very important. If your attitude is good, everybody will help you. If your attitude is not good, then that's difficult. Okay, so let's wait for a few minutes. Very good morning once again. Let me start. Students, any doubts so far? Students, any doubts or questions? So when I mean in common for both G1 and G2, any doubts?
No doubt, sir.
Okay. For G2, the next experiment in the lab is equalizer. Design and implementation of a tapped delay line equalizer. So I thought I can spend few minutes for that. So that today is Wednesday. They have the lab on Tuesday. Only then they can start the programming. How about G1? Did you do this experiment? Equalizer. Students, you have to interact. I will finish sharply by 9:30. Students, everybody can interact. Just you simply say yes or no. I won't ask lengthy question and then just I will ask only one line question. No. So students, I'm not sure when G1 have this experiment, whatever it is, even for G1 regarding theory, unit theory, because the lab faculty cannot tell you everything. So I will spend few minutes in talking about equalizer. Then I will start line coding. Students, you have to interact. Again, I am telling, you are in final year, you must be mature. I am in constant touch with our dean placement. Even on when is it? Monday evening is when I was leaving the college, the dean placement asked me, are your students happy with the placement? The dean placement. Yes, I said, I replied them that students are very happy. So even the dean placement said the attitude is very important. If your attitude is not good, then naturally problem will come. With my experience, I'm telling, it is all about the attitude. Now we have to start the class. So let me start about equalizer. Just not in detail. I will not spend more than 50 minutes for sure. Just very simple thing. Just a few things. Just maybe around 5 points. Not more than that. The first one, I'll tell you about equalizer and then the concept of tapped delay line. Just while closing, I'll talk about this tapped delay line concept. Because CA2 is over. Now we are going towards end of the semester. You will have the lab exam, you have to complete the experiments. So that is the objective. What is an equalizer? Equalizer is nothing but dash. Just you tell me. One thing is you can define equalization. Another thing is you can define, let us say, the hardware or the system. Let me not say the hardware, the system equalizer. So let me repeat. I need two definitions. Equalization is nothing but what? The system equalizer is nothing but what? No, Aditya, it is not compression, Aditya. Aditya, it is not about compression. No, equalization has nothing to do with compression. So before that, in like our syllabus is okay, it is not, let me take communication. Yes, we are into communication. Mainly, but till even we spoke about story communication also. Communication can either be telecommunication, where the transmitter and receiver are far apart by distance. They differ in distance, but time can be the same. Now, what is happening? I am lecturing. So this is basically telecommunication. Today I am at my house, like I got the permission, I am handling that from my house, and then you are all at your houses. But what about the time? Time is constant. Same time, different place. That is telecommunication. What is storage communication? Same place, differs by distance. What is the example? Recording and then playback. Storage communication is you can record the lecture, even I can record the lecture. I can record the lecture. See, I can play back. Is that right? I told you I'm having mild head heaviness today, so I can play back. How was my lecture today? Did I speak properly? So very well, sitting at my house, the same place, maybe after some time, I can listen. That is storage communication, recording and then playback. So coming to our concept, equalizer. Equalizer is used in telecommunication. Equalizer is used in telecommunication. Where is it used? Yes, Karishma, your answer is correct. I will fine tune Karishma. I will fine tune your answer. Students, you have to interact a lot. Students, equalizer is used. Where is it used in telecommunication? Which block? Equalizer is used where in telecommunication system? Let me give you the clue. Is it used at the transmitter section or the receiver section? Equalizer is used in the transmitter section or in the receiver section?
Sir, receiver, sir.
Yes, that's correct. Sharon, you can reply in the chat box, Sharon, because that's better. Unless I tell anybody that switch on the mic and then answer, because it's better. There is no interference and all that. So that's okay. Now we are starting. Karishma is correct. I have to fine tune the answer of Karishma. And then equalizer is used at the receiver. Like you know about pre-emphasis, de-emphasis, and then encoding, decoding. Yes, you know about encoding. Encoding happens at the transmitter. Decoding happens at the receiver. In a similar way, equalizer is used at the receiver. Something like return. It is used at the receiver. Now comes the question. So let me fine tune the answer of Karishma. Equalizer is nothing but a filter bank. Equalizer is nothing but a filter bank. I will tell you what is a filter bank. You know about filter. Filter, you know. Equalizer is a filter bank. Or you can define equalizer one more. Filter bank is right. Because, is it an amplifier or is it a rectifier? It's a filter bank, filtering. How will you define equalization? So now we are getting into the topic. How will you define equalization? It's a process. Like amplification, rectification. Equalization is nothing but what? I would have told, I'm not sure. Like, what should be done at the receiver? Students, you listen. So, if source coding happens at the transmitter, you have to go for source decoding at the receiver. Channel encoding, channel decoding. Something like pre-emphasis, de-emphasis. Now you say equalizer happens at the receiver. What for? So, what happened at the transmitter side? Is that right? Why are we equalizing? Why are we equalizing at the receiver? What is the need? So what happened at the transmitter? Students, now can you answer? Why are we equalizing? What is the need? Okay, Sharon is exactly correct. Sharon, be genuine. Sharon, be genuine. Did you Google for this answer or is it your answer? You can be genuine. I won't mistake anybody. I don't have any image also because you're all students. Now we cannot expect you to be something like a mature person. Because you're all students, is that right? Students can be naughty. I was a student. Students can do mistakes. Anybody can do mistakes. Even I can do a mistake. That is I came to know that regarding G2, something in the CA2 question, there was a small mistake. I have to correct it and all that. So Sharon is exactly correct. You can read the message of Sharon in the chat box. Let me not look at that. Let me tell you. So it is not about the transmitter. Let me define equalization. There was a background noise, so I muted the mic. Equalization is to compensate for the channel distortion. Please underline compensate. Equalization has nothing to do with the transmitter. When, let me tell you in a simple way, when the signal is transmitted in the channel, it could be a binary symmetric channel, eraser channel, anything can happen in the channel, in the medium. That is attenuation, phase distortion, reflection, refraction, diffraction, anything can happen. So, equally, so it is about the channel, the communication channel or the medium. So, there can be any unwanted effect, undesired effect, unwanted effect, undesired effect. So, it is distorted. So, what we know is attenuation and then phase distortion and so on. Equalization is to compensate for the channel distortion, because we have to reconstruct the transmitted signal. As a digital communication engineer, we have to remove, we have to nullify or remove the effect of channel. It is introduced in the channel. Say when you go out, what happens? There is all pollution, air pollution, noise pollution, everything is there in the outside. So generally leave alone this pandemic, COVID and all that. Leave alone the COVID pandemic. Now things are getting normal. Even before COVID, what happens? When we go out, say when you drive, you wear a helmet. Even some people even those days they'll be wearing gloves and all that. So when you come back, it's good to take bath. Always it's good to take bath, is that right? Take bath, wash your face and then get refreshed. Because there is pollution outside. Always there is pollution outside. The same thing, it is to compensate. Equalization is nothing but to compensate for the channel distortion, undesired effect. So did you learn about compensation? In which subject did you learn about compensation? Can you tell me? In which subject did you learn about compensation? I don't know, today the strength did not cross 100, let it be. And always I want natural response. Please attend the class if you want to attend the class. Say, I want to handle a class today, I'm handling. Nobody, HOD or nobody told me, Venkat, you have to handle a class today. I can say, ma'am, I need to prepare the thing. It is a combined class. I can say some reason. I can cancel the class. I can start the class at any time. So I am repeating, be natural. If you want to attend the class, attend. Today the strength is till now 96. It's fine. It's natural response. So now today we have to complete equalizer for sure. So it's a very important topic. So students, you tell me what is that? In which subject did you learn about compensation? Come on. Just a few more concepts. For sure, I have to complete by 9 o'clock. In which subject did you learn about compensation? Yes, control system. I only handle the subject. Is that right? What about others? Students, what happened to the boys, other students in G1 as well, G1 and G2? Is there any problem? Shall we close the class now? If you don't feel well, okay. Aditya, I'm sorry, I did not see your message. Other than Aditya and Sharon, what about, like, I know many girls in G1 used to respond, interact. What happened to them today? They're not feeling they're not feeling well today. Okay, let's wait. Students, please, I need your cooperation. Without your cooperation, I cannot handle the class. I need your cooperation. So we learned this in control system, compensate. Let us not talk about the type and all that. So now listen, what is the layman example? What is this compensation? Say you go for a sports activity for a month, or NCC or NSS training for say for 2 weeks. So when you come back, you have to compensate, is that right? Leave alone everything. You have to write down the notes. You have to complete the lab experiments. Since you missed the classes, let us talk about the lab experiments or the tutorial or the test. You have to compensate. You have to compensate for your absence. That is what is happening here. As Karishma said, what system it is? It is a linear, it is a filter bank. Equalizer is a filter bank. What is a filter bank? Bank means collection of filters. When I say bank, it is a collection. Say I have a toolbox. In my toolbox, I will have so many pens. Red pen, blue pen, black pen. I cannot use green pen. So for some reason, I've got 3 pens. Blue, black, red. I can have so many pencil and then all that. So filter bank means collection of filter. What is this? Why you talk about filter bank? Because we don't, okay, let me give you the layman example. Let me give you a layman example. You went like, say you went to college today for some work, you're returning back. So after you come back, you may feel tired. I'm telling for the entire class. You may feel tired. Either you may ask for a coffee or a tea or a milk or a fruit juice or a Bonvita or Boost or anything of your choice. So all that must be there at the home, is that right? You need an energy drink. You feel tired after returning from college. You may ask either for a coffee or a tea or a milk or a fruit juice or anything of your choice, something to drink, or even you say water. Just happy with the hot water or the cold water, whatever it is. In a similar way, we don't know what channel disruption happens. So what we should do, we should have all filters. What is this? Can we have all filters? Infinite? No. I mean, have low pass filter, high pass filter, band pass filter, band stop filter. Low pass filter is fine. What cutoff frequency? I don't know. So it is good to have a collection, but that doesn't mean we can have infinite things. So that things have to be variable. You can refer the literature. You can refer the material. So it is called the filter bank, collection of filters. So equalization is nothing but compensation. Equalizer is nothing but a compensator. What system is that? It is a filter bank. So that filter will nullify the effect of channel distortion. That filter will reduce the effect of channel distortion. The last 5 minutes, I told you it is a tapped delay line equalizer. Let me tell you about that and then start this. So any doubts so far, students? So you see, it is basically an introduction. I did not get into the block diagram, the mathematical equation and all that. But even the introduction is very important. What is it? What is the name? So it is about tapped delay line equalizer. Tapped delay line equalizer, or the other name is transversal equalizer. It is not traverse. Some people get confused. Traversal is different. It is transversal filter. Tapped delay line equalizer or transversal filter. So what is this tapped delay line? Listen. Filter. Any system is a filter. Any system is a filter, that I told you already for you. Any system will have a frequency response. Any system will have a frequency response. Any system is a filter. Any system can operate only in, any system will have a bandwidth. Any system will have a frequency response, will have a bandwidth, it is a filter. So that's fine. So system means, we can let us assume that to be LTA system. Let us assume that to be LTA system. So we can find response output using convolution. We can find the response, the output using convolution. So regarding the output now, let me say y of n. This is basically a DC system, or it could be listen. Now, I think we generally talk about FIR filter. This task delay, let us talk about FIR filter itself. Let us not get into IIR. Even you can assume this to be a FIR filter. This y of n. So let us say, and then since convolution is commutative, you can say y of n is equal to summation x of n h of n minus k. That formula is okay. I'm not going for that formula. Rather, I will go for the formula summation h of n x of n minus k. Let me repeat. Convolution is commutative. I can say y of n is equal to summation x of n h of n minus k. I am not going for that formula. Rather, I am going for the formula summation. I am not going for summation and all that. Summation x of n into h of n minus k. Summation x of n into h of n. I'm sorry. I'm not going for this. Students, I'm not going for this. Leave it. Say I did a mistake. Fine. This is correct. I'm not going for that. Rather, I'm going. So only today I have to be careful. I'm going for the thing h of n into x of n minus k. So what does it mean? Students, try to visualize, because maybe in the next class I can show you the diagram, because now I don't have the diagram. Maybe in the next class, in the starting of the next class, I'll share that block diagram. So what is this? Summation h of n x of n minus k. So this x of n minus k is called as delay. So okay, let me tell you. Again I did a mistake. Sorry. I'm sorry, just I have to be careful. Just let me spend 5 minutes. H of k into h of k into x of n minus k. H of k into x of n minus k. This is the correct one. Students, you see here. Now what happens? You try to visualize, or you can visualize. Listen, students. You think about the horizontal one. Maybe I can show you the block diagram in the next class. Now, since the semester is almost over, try to visualize. In the horizontal block, horizontally, you think of so many delay elements. Z bar minus 1, Z bar minus 1, Z bar minus 1 unit delay. Let me tell you first and then explain you once again. Horizontally, you think of so many unit delay elements. What is the input? Input is x of n. Input is x of n. The first block is unit delay element. D flip-flop unit delay element. What is the transfer function of unit delay element? Can one of you type in the chat box? Can one of you type in the chat box? What is the transfer function of unit delay element? Students, come on. Students, come on. Can one of you type in the chat box? What is the transfer function of the unit delay element? Students, the last few minutes, to complete this topic. Yes, Aditya is correct. Z bar minus 1. Z bar minus 1 is the transfer function of the unit delay element. Now, horizontally, you visualize so many unit delay elements. What is the input? The input is x of n. After the first block, the output will be x of n minus 1. After the second block, the output will be x of n minus 2 and so on. Now, vertically, with x of n, vertically you connect the weight h of 0, x of n, you can because listen, summation, and this is a FIR filter, summation a equal to 0 to n minus 1, summation k equal to 0 to n minus 1, h of k into x of n minus k. So let me repeat, x of n will go with what filter coefficient? You call that as filter coefficient or filter tab, that is h of 0. X of n minus 1 will go with the filter coefficient of the filter tab, h of 1, and so on. Finally, there will be a summer. Everything will, summation is there. Summation go for a summer. What is the output? The output y of n. So let me repeat this and then complete this topic. The block diagram I will show you next. Horizontally, you visualize n. I think n is enough. You visualize n number of unit delay elements. Capital N. Capital N is filter order. No, it is not. Capital N is the, I think capital N is the filter length actually. Okay, let me be careful. Capital N is the FIR filter length. Capital N is the FIR filter length. Number of filter coefficients. So what is the filter order? Filter order is n minus 1. Filter length is n. Filter length is n. Number of filter coefficients. So let us visualize n number of unit delay element. Horizontally, the input is x of n. After the first delay, x of n minus 1. Second delay, x of n minus 2. Very simple, students. Today is Wednesday. Yes, today is Wednesday. Today, minus 1 day. Tuesday, yesterday. Then minus 1 day before yesterday. We are going back. Today, yesterday, day before yesterday. Now you are in 7th semester. Let us go back. From 7th, we have to go to 6th. From 6th, we have to go to 5th. Regarding 7th, we have to go for the corresponding GPA. 6th, we have to go for the corresponding GPA. X of n. The primary input x of n will go with the what is that? H of 0. So listen, students, I will close this topic. Summation k equal to 0 to n minus 1 h of k into x of n minus k. So when k is 0, what do you get? You get h of 0 into x of n minus 0. What is x of n minus 0? X of n, what is this h of 0? That is the filter tab or the filter coefficient, or it is the weight. You can say h of 0 is the weight. Next one. What is the next one? H of 1. H of 1 will go with x of n minus 1. Then finally, listen, you are having every semester you have GPA. Listen, in a semester, let us talk about one semester, that is the semester every subject you have a grade in a semester, every subject or a course you have a grade. How will you find the GPA? GPA, you have to basically go for sum of products. The same thing, horizontally unit delay element, vertically that weights are there. Finally, you have to go for a summer. What summer? N input summer. Because you have to add anything. Finally, you have to go for a summer. What is the output of the summer? Can one of you tell me what is the output of the summer? So I'm done with this. With this, let us close the topic of equalizer. This is tapped delay line. What is tapping? We say tap the telephone line. Tap the telephone line. This vertical tapping. Tapped delay line is horizontally delay. Yes, you learned about what is that? Transmission line and all that. Tapped delay line equalizer. You tell me what is the output of the summer? Students, today I did not get any response from G1 girls. Why? What is the reason? You're not happy with the class? Shall we log out now? It's time 9:10. Thank you for your cooperation and sign off because I'm not getting any response. Till now, I did not get any response from the girls in G1. So if you're not happy with the class, let me sign out. What is the output of the summer? Students, what is the output of the summer? I need response from some girls in G1 or other students. If you don't respond, I will log out. I will sign out. Thank you. Shall we log out now? What is the output of the summer? Students, what is the output of the summer? I told you horizontally you need delay element. Vertically you have got the filter tap. What is the output of the summer? You add all this. I have typed two terms. First term plus second term, you will have n number of terms. What is the output of the summer? Students, I told you clearly, is that right? What is the output of the summer? Students, I need some response from girls in G1. Aditya, can you say what is the output of the summer? Students, what is the output of the summer? Karishma, Sharan. What about others? Karishma, Sharan. What about others? What is the output of the summer? When you add all these n terms, I told you. Clearly, is that right? Sharan? Sharan, Karishma, roll number 1, Abhiga, Rahul, roll number 1, Abhiga, Rahul, Siranjeevi, Rajkumar, 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 the output of the summer is V of n. The output, what is the output of the summer? Output signal. You are adding the n terms. What n terms? You are adding h of 0 into x of n plus h of 1 into x of n minus 1 and so on. The summer output is what? The output signal or the response y of n. That is what is convolution. Summer output is output of the convolution. Summer output is output of the convolution. So what happened to G1 girls today? Like normally Kartika, Harini, they will all be responding. Karishma, can you share the PPT on line codes? No? Just I will start today. Okay, before that, Karishma, can you share the last 15 minutes? Students, any doubts so far? Students, the output of the summer is the output signal or the response or the convolution output y of n. Students, I need your cooperation. Without your cooperation, I cannot go for a combined class. So students, you listen. Regarding line, any doubts so far? Any doubts? Line coder is mandatory. In digital communication system, source coding is optional. If you go for source coding, compression will be there. If you go for channel coding, error detection and correction capability will be there at the receiver. But line coder is mandatory. Without line coder, we cannot transmit ones and zeros to the receiver. We cannot transmit them in the channel. Source coder is for compression, optional. Channel coder is for error detection and correction, optional. Line coder is mandatory. Only then we can transmit ones and zeros in the physical medium to the receiver. So that is one thing. Next thing is the other name. We talk about line coding scheme. It is basically digital baseband signaling scheme. I told for G2 students, the typical name for line coder is digital baseband signaling scheme. The typical name for line coder is digital baseband signaling scheme. So hereafter we'll go ahead with the lecture, the last 15 minutes. Students, any doubts so far? Any doubts or questions or clarification? Karishma, can you share the PPT on line code? Students, any doubts? Karishma or Rajkumar, one of you share. Just a minute. Yes, Karishma, it is visible. Karishma, it is visible. Can you go to 20, page number 20, slide number 20? Okay. Students, the last 15 minutes, I'm not sure about G1. Listen, students, like we talk about line coding, block coding, and then scrambling. Line coding, block coding, and then scrambling. Block coding is not there in our syllabus. Since block coding is not there, we won't talk about multi-level and multi-transition. Omit that. We don't have block coding. Scrambling. Why we have to go for scrambling? Because we have to ensure transparency, faithful reconstruction at the receiver. Even when you have a long continuous occurrence of ones and zeros, look into scrambling, discuss with G2 students, I told them. Regarding line coding, we can categorize line coding into unipolar, polar, and then bipolar. Many students miss this polar. Yes, polar is there. We can categorize line coding into unipolar, polar, and then bipolar. Unipolar, further, unipolar is basically NRZ, that is on-off signaling. Just I will show you the unipolar thing now. Just I'll show you all that, what we discussed for our students. So with that, we will close today. Just a recollection. Unipolar is NRZ. The other name for unipolar is on-off signaling. Please correct me if I am wrong. Please correct me if I am wrong. Please ask if you have any doubts. Okay. Polar can be NRZ or RZ and then biphase. Polar can be NRZ, RZ and then biphase. Bipolar can be AMI and then pseudo-ternary. And then biphase can either be Manchester and differential Manchester. Biphase can either be Manchester and differential Manchester. So for G2 students, I completed till RZ. I was about to start biphase today. I will do that on Saturday first. So before that, the last 10 minutes, quickly for both G1 and G2, we will look at the remaining schemes. If I commit any mistake, please tell me. If you have any questions, you ask me. Karishma, you go to that signaling scheme, NRZ signaling. Okay, listen. This is NRZ. So what is NRZ? On-off signaling. 1 is on, 0 is off. Is that correct? Let us not worry about the bandwidth and all that. NRZ is on-off. Next one, Karishma. Regarding polar, we have NRZ level, NRZL, and then NRZI. Go down, go to the signaling. Just let us look only at the diagram today, Karishma. Karishma, okay, fine. NRZL is what? No inversion. NRZL is no inversion. So here, what happens in non-return to 0? It does not return to 0. It does not return to 0. Polar, non-return to 0. 0 has got one level. I told the students, what? You assign one level for one symbol, you assign opposite level for another symbol. Symbol 0 and symbol 1, they have to be exactly opposite in signaling. In line coding, if you assign a level for symbol 0, you have to assign a different level or value for symbol 1. So here for symbol 0, we assigned the positive value. Symbol 0 is positive, symbol 1 is negative. Symbol 0 is positive, symbol 1 is negative. What is NRZI inversion? The consecutive thing, they get inverted. Listen, NRZI. If the next bit is 0, no inversion. If the next bit is 1, there is inversion. Next bit is 0, no inversion. The next bit is 1, there is inversion. So we are starting 0. Next bit is 1, there is inversion. Then 0, no inversion. Next bit is 1, there is inversion. Next bit is 1, there is inversion, and so on. Okay, go to the next one. So we are done with NRZI and all that. Now we have to go to RZ. Listen. This is polar RZ. Regarding polar RZ, return to 0. return to 0. So there will be a transition. There will be a transition. So regarding 0, what happens? Okay. It will come to equilibrium. Return to 0 means what? Every symbol will come to the 0 value. So regarding return to 0, you listen. The binary symbol 0, half the duration, the binary symbol 0, half the duration it is off, that is negative value, half the duration off, and then 0. Regarding 1, you have to go for the ulta. Half the duration is 1, and then it comes to what? It comes to rest, it returns to 0, and then 0. Regarding 0, the same thing. Regarding 0, the same thing. So do you understand? Return to 0. So let me repeat. I did not tell you one thing, students. In line coding, we have to decide the bit duration, capital TB. We have to decide the bit duration TB. The bit duration TB has to be the same in all line coding schemes. The bit duration TB has to be the same in all line coding schemes. And then it returns to 0. This we discussed in the previous class. 0, half the duration is off, negative value, it returns to 0. Regarding 1 is exactly opposite. 1 is exactly opposite, and then you have it for 0. Okay. The last 5 minutes, let us see what we can do. Go to the next one. Next slide. Okay. So this we will discuss in the next class. Like, go to the theory itself, Karishma. Because this I did not discuss this for G1. Okay. This is polar biface. Polar biface can either be Manchester and then differential Manchester. So this I will discuss in the next class. Karishma, thank you for sharing the screen. You can stop sharing. Wait. Let us wait. Do not stop sharing now. Students, any doubts so far? Students, any doubts or questions? The last 5 minutes. So next week, not next week, next class, I will complete the line coding and then start the power spectral density. Okay, the last 5 minutes, any doubts? So G1, I hope you learnt about line coding in computer networks, but then you would not have learnt about the autocorrelation function and then the power spectral density. That is the only thing. Students, any doubts so far? Any doubts or questions? G1, whether the line coding schemes, what I discussed is correct? Any mistakes, any doubts? So the last 5 minutes, Karishma, you can stop sharing. The last 5 minutes, we will talk about autocorrelation function. So correlation, let me ask you two questions and then complete the class today. Correlation is nothing but what? And then I give you a clue. Correlation is similar to convolution. Correlation is similar to convolution. Just I'm going to ask you two questions. With this two questions, I'm going to complete the class because we don't have time. Correlation is nothing but dash. I mean, can you fill up in some 2 or 3 words? Students, come on, the last 5 minutes. Students, I will be very happy if I get some reply from G1 girls. G1 girls, till now I did not get any reply. Normally, with the girls, Abhika, Kartika, Harini, and others, many girls in G1 used to respond. I forgot other names also. I forgot other names in G1. So I'll be very happy if I get reply from G1 girls. Correlation. Leave alone autocorrelation. Correlation is nothing but dash. What is it? Correlation is similar to convolution. Correlation is nothing but, what is it? Students, come on. I told you, what is it? I don't know what is correlation. Correlation is nothing but what? Kartika, are you there? Kartika, Harini, Jayashri. Harini, you are correct, Harini. But in that is the Harini, please respond. What happened? I'm telling, I'm not. All of you are equal. Students, I am very frank. I don't have any. I need not tell you something false. You to praise you, to please you, to please you, to praise you. I need not talk. I'm very frank. All of you are students. All of you are final year students. What is the difference? Nobody is a VIP. Grade doesn't matter. Grade, placement, nothing. I've seen so many batches. Okay, the last 2 minutes. So I'm very happy. Thank you for your responses. Harini, your answer is exactly correct. And then Kartika, your answer is just broad. Harini, regarding engineering, correlation is nothing but a signal operation. Signal operation like convolution, like what is that? Folding, shifting, and then scaling, multiplying. Correlation is a signal operation which involves, okay, correlation is a signal operation. Does it involve operations only in the independent variable or in the dependent variable? So with this, let us close today because I'm not going for the second question because it's not fair. Time is over. The last 1 minute. Harini, can you reply whether correlation is a signal operation? Does it involve operations in only in the independent variable or in the dependent variable or in both? No, like convolution. Like convolution, it involves operations both in the independent variable as well as in the dependent variable. Both, because it is basically a summation. Think about autocorrelation. What is autocorrelation? R of k. R of k equal to summation x of n into x of n minus k. Please look at the formula. Autocorrelation is R of k. R of k is equal to summation. R of k is equal to summation x of n into x of n minus k. Correlation is a signal operation which involves operations both in the independent variable and dependent variable. With this, I am closing the class. Students, all of you, please look at the formula for correlation. All of you, please look at the formula for correlation. I'm concluding the class. Is that fine? The time is 9:30. So next class, I will complete line coding. G1 students, please bear with me. G1, please bear with me. I will complete line coding and then start power spectral density. Thank you. Shall we close the class now? Thank you. Thanks to all of you. What happened to you today? Shall we close the class now?
Yes, sir.